A worker is starting endowment fund for his charity. The fund will accumulate at nominal annual interest rate 12% convertible monthly. Beginning today, worker will deposit 500 monthly for 10 years. No deposits or withdrawals will be made for the subsequent 10 years. Exactly 20 years from today, monthly payments of X will be made to his charity and continue forever. So, uh, since the payments are made monthly, so we need the monthly effective rate. So the nominal rate is 12%. So the monthly effective rate J would be the nominal rate divided by 12. And so that would be 0.12 by 12 equals 0.01. And the contributions are made for 10 years. We need to find how many months there are in 10 years since the contributions are monthly. So there are 10 times 12 equals 120 months. So what we will do is we will calculate the accumulated value of the deposits, and we'll move that accumulated value to the time when the first payment is starting, the first payback is starting. And since deposits are made for 10 years, so if we use and they're annuity due because they start happening beginning today. So if we use the accumulated value formula for annuity due, that will give us the value of the deposits exactly at 10 years. And so, because the accumulated value it sits one period after the last payment, and the last payment will happen 1 month before 10 years since it's annuity due, and so the accumulated value will be exactly at 10 years as found by the accumulated value formula, which says that you have payment times 1 plus I power n minus 1 over I, and then times 1 plus I. Remember, for immediate, we don't have this 1 plus I factor, we just have this part. And for due, we just multiply it by 1 plus I. And the effective rate in this case is J, which is 0.01. And there are 120 months, and 500 is each of the contributions. So the total contribution value at time 10 years would be 169.54. And we need to push this to time 20 years because that's when the income stream starts. And so to push it to 20 years from 10 years, we have to push it forward by 10 years or another 120 months. And so multiply it with 1 plus J power 120. And therefore, the value of the deposits at time 20 years is 383,404. And this will be also the value of the perpetuity due that starts at time 20. That's the income stream. And the formula for the perpetuity due present value at the time of the first payment, which is exactly at time 20 years, it's X times 1 plus J over J. And that value we already know should be 383,404. I don't know. Okay, it looked like I had a decimal, but I didn't. Okay. So then J is 0.01 and X could be found from this equation by multiplying by 0.01 and then dividing by 1.01. So X comes out to be 3796. That is choice D.